Hi, welcome back. So up next we have James from Google and Bruce from Mindview LLC. They're going to do a tour of the modern Java platform. They're both very entertaining people. They have their own podcast called happypathprogramming.com, so check that out. And we're ready for you guys to learn more about the improvements in Java. Go ahead.
Okay. All right. Well, welcome everyone. Thanks for joining us. I'm James Ward.
I'm Bruce Eckel.
And we're together in the same place in Crested Butte, Colorado.
We are. We just happen to live in a little town.
That's right.
Yeah.
Yay us. We get to do this conference together.
Mm-hmm.
Wish we could have all of you with us, or we could be with all of you. But yeah. Okay, so we're going to do this tour of the modern Java platform. Bruce and I have been working with Java for a while. I think
pretty much since the beginning, I think.
Since the beginning. I actually learned Java from your book.
Did you?
Yeah.
Oh, well, thank you.
Yeah, I was doing Perl and, all that
I
stuff
rescued you from Perl?
You rescued me from Perl.
Oh, that's good to know.
Yeah. So, yay, here we go. Okay, so we're going to start out with learning about some of the new Java language features that we consider modern. And modern is kind of a weird word. It's a relative word. It's like what is modern?
Well, between World War I and World War II, that was considered modern. And after World War II, it was postmodern, which means that modern meant that they were still enthusiastic about the world. Postmodern meant that they were depressed about the world.
Okay, so these are things we're enthusiastic about.
Okay, if you say so. All right, let's look at some features.
Let's look at some features. So this is the repo that we're going to be going through first. It is just some Java language features that we wanted to highlight, which we think are actually great improvements for the Java language. We'll later get into Kotlin and see some other things. But let's start with Java and some of the great things that Java is doing. If you're a Java developer and want to stay a Java developer, then there's some good things happening for you.
So records.
These
are cool because most of the other modern languages have them now, and they eliminate the need for a whole bunch of boilerplate.
Yes, this is like a POJO, I guess we would
plain
call
old
them.
Java object, yeah.
And you would have to generate getters and setters and toString and equals and hash code and
people have had to do this a lot, and they've had to put in the boilerplate, and they've gotten it wrong. Yeah, because you have to do the comparison operations correctly and everything.
Yeah.
And one of the things about the record is that the arguments to this are immutable. So what this does is it creates a class, and it creates a constructor for the class, which takes an int x and an int y, and it makes those automatically final. So if you pass it around, it can't be changed.
Yeah, and that's a good thing, right? Like I remember when I switched from kind of mutable programming to immutable programming, I was like, why am I doing this? Like this just seems like a pain. Like it's making everything
the immutability. Because you can't change anything when you want to.
Yeah. So it seemed like it was just like adding pain to my life, but now I love it.
Right.
And I think I love it because this kind of enforces this boundary around where mutation happens, and it makes my programs much easier to understand, because I know that unless I see a new instance of this thing, or if we're using other languages like a copy method or something like that, that what I'm getting hasn't been mutated underneath me by something else.
Right. So you don't have to think, oh, how did this get changed?
It just creates a rational flow of mutation. Immutability creates a rational flow of mutation.
Yeah. In functional programming, we say that it makes it easier to reason about.
Yes.
So if it's not changing underneath the covers. Now, full disclosure. So this is coming after Scala has data
case classes.
Scala, Kotlin has data classes. Python added kind of
something similar.
I think it's actually a data class decorator. So they've come along with this, but it's missing something.
Oh, we will get into what it's missing.
Okay. All right, let's do that.
So anyways, we can see this new syntax here. This is coming in JDK 17, which is the next long-term release.
We always
get
I'm totally confused about the release.
I think it's coming this month is essentially what
I guess, but I
think
it might already be there in some form. I don't know.
Oh, right. Maybe you have to enable preview
or they might have put it in 16. Anyway,
if you're doing Java,
it's very confusing.
And you get to Java 17, the next LTS release coming, I think this month, then you should start using records. It
makes your life easier. Well, and there's libraries, like third-party libraries that implemented this.
Like Lombok.
Yeah. So they've been doing it for a long time.
Yeah, but now it just becomes like a core language.
Okay,
thing,
so on we go.
Okay, on we go. Okay, so we've got our great records. And then we're going to show off one other new feature, which we're kind of covering new features from, I don't know, the past few years, because they're not features that are universally used yet. And I think Java 17 will make a lot of these features more readily used because it's the next long-term release
after 11.
Yeah, after 11. So we've got this var thing. What is that doing? I've seen that in Kotlin and Scala. But.
So we get type inference here. So notice you don't have to say what the point is.
So I didn't have to do like point.
Yeah,
that just seems repetitive.
Also, you don't even have to do a diamond, I don't think, when you're dealing with generics.
Generics, true. Yeah. So it's just going to infer based on the right side what the type of this thing is. So that's nice. That's a good thing. Okay, and we mentioned mutability, and I just want to show hey, if we try to set X, IntelliJ even, and of course our compiler is going to be like, you can't set X, that's not
because
it's valid. So that's why we have that.
It's immutable.
Yeah.
And down here you can see that one of the things that records create is toString.
Just a nice toString out of the box.
Right.
That's good. Yeah. And we should run this thing so we can see it. Before we run it, let's talk about the text box.
Oh, yes.
We'll see that. So
also,
another new feature,
Python feature, which has been around since the beginning of Python.
So we don't have to have those annoying plus signs at the end and the new string thing at the beginning and the next line. We can just say, hey, this thing is a multi-line string, and then it preserves the new lines and all that, right?
I'm happy that this is here, but I'm also annoyed that it's taken so long because other languages have had this, and it seems like the only thing that's kicked them into doing it is all the other languages having these,
and maybe at some point we'll get string interpolation, but that's another.
Oh, that's right. There isn't string interpolation. That's why you're using the printf here.
That's If I've never even used printf. I don't know. Maybe that came at some point after I stopped using Java.
No, it's been around, I think, since the beginning.
Yeah. Okay, let's run this thing so we can see what this actually looks like. So if we check out the Gradle output here, we see, there's our nice toString method on that record.
So that was automatically generated, and that's a nice thing to have for sure. Yeah.
And then here's our output from our text block, our multi-line text block there. So
it's got the built-in new lines.
Yeah. So that's nice. Okay, and here's I think one of the really nice things that they've done with records is they've made it so that if we put a bunch of record instances into an array, then there's some really fancy memory compaction that happens there. And so for memory's sake, this is really important because we don't have to have the overhead of a whole class shoved into each slot for this array. Instead, we just get the actual values that are part of that shoved into there. So this is going to use a lot less memory in arrays specifically.
Oh, I see. Because otherwise it would be all the overhead of the class that comes when you create an object of a class.
Yeah.
Okay. Bunch of pointers and whatevers.
Yeah, a bunch of whatevers.
So it's just the data.
Yeah, just the data.
That's nice.
Yeah, so that's nice.
Yeah.
Okay, so that's some of our nice new language features there. So we've got records, we've got type inference, and then some nice features on records. And as Bruce mentioned, which we didn't go into details on, is unfortunately the lack of a copy method. So sometimes you do want to create a mutation of a record. And in the case of Java, as far as I know, I think there's some libraries that help with this, but
we couldn't find it.
Yeah, you need to just create a new one. Whereas other languages that do things like records, they usually have a method called copy on it, which allows you to. They all do. Yeah. They allow you to just change one property inside of a record and not have to have much syntax overhead for changing one property and get a new instance. So anyways, no copy method. I'd say that's one of the downsides of records.
It's an odd choice, but I'm sure they must have known about it.
They'll get to that.
Yeah. Okay.
Okay. So that's some fun stuff. in Java. Okay, now let's take a look at an example where we're going to see a new feature. I don't remember. We should have put in here which versions these were added in, but hey, all that matters is Java 17 because it's coming out soon. So what we have is we have some records. We've got Plumbus. What is a Plumbus?
Well, it's the most purchased item in the universe.
Oh,
and everyone needs one.
Okay.
It's from Rick and Morty.
Kind of like unobtainium or something.
Well, apparently that's a real thing.
Oh,
it's on the periodic table. It just has a silly name.
A Plumbus is on the periodic table?
No, unobtainium is.
Wow.
Yeah,
huh.
no, Plumbus is from Rick and Morty, and so is meeseeks.
Oh, okay. So we've got a Plumbus, a thing has a Plumbus, and then a meeseeks has a thing. So we've got this just, hierarchy. What would you call that? A hierarchy?
It's a composition of records. It's not a hierarchy.
Okay. So then we're going to create some of these. We're going to use our fancy type inference here, and we're going to create a meseeks, which has a thing, which has a Plumbus, the Plumbus has a string, obviously. And then we're going to create one where our Plumbus is null. So because nulls are a thing, we're allowed to do that. Then we're going to use this nice new syntax, again, added in some recent version of Java, to create a collection, which is, in this case, a set, and we just give it our two meseeks. And then we're going to use our for each on that, which takes a nice, if you're not using this like function syntax for doing iterations or maps, or what else do we have? Folds, like any kind of operations on collections, it's time to switch over
to
lambdas. Yeah. Yeah, exactly. So we're using a lambda here, and we give it the parameter name, and then
we should point out
the
that
body.
It actually is just an identifier. In Kotlin, it is a reserved word.
Yeah, it's true. In Kotlin, you just say that, but
you just do that, but we have to do it this way.
Okay. So they don't have like fancy lambda syntax in Java yet, but we'll get into some of that with Kotlin a little bit. Anyway, so then we're going to print out our it, which is our meseeks.thing.plumbus.s, so the actual string inside of our Plumbus. Now we got to run this thing so we can see what's actually going to happen here, because we get a null pointer exception, as you may have guessed, but they added a really nice null pointer exception here where we see cannot read field s because it.thing.plumbus is null. So man, that's really helpful if you're still dealing with nulls in your code. I haven't got a null pointer exception in a long time because I use other languages, but but if you're still doing nulls and null pointer stuff, getting null pointers, then this is going to be really helpful for helping you troubleshoot runtime errors that really should just be compile time errors. But
again, that's something like, wow, how long have they been able to do this and not done it? Just made people suffer through spews of exception traces.
Yeah.
Anyway,
I mean, they've got this huge anchor that they just drag along.
It's Jacob Marley's chains.
Yeah, exactly. So, I'm glad to see that there's improvements, and if you're dealing with null pointer exceptions, this is going to be massively helpful.
And it's amazing that they've been able to do what they have, considering what they're dealing with.
That's right. Yeah. Okay, so that's our null help. Okay, so now let's move on to another new feature, which is in our bucket of modern. And
Java has robots now?
Yeah, it got robots.
Excellent.
Yeah, and you can just tell them what to do.
Robots.
Yeah, you can create vacuum robots, snowblower robots, and lawnmower robots.
I want them all.
The robots, yeah. So they added this new thing called sealed, and we can put sealed on different types of things. So we can put it on classes and interfaces and records, I think even.
Did sealed start in C#? I mean, it's in every other language now, so.
Yeah.
It's not really new.
So tell us what sealed is doing. What is this?
So the idea is that you want the compiler to be able to say, have you covered all the cases? And so by saying that it's sealed, you're saying, here are the only subclasses that are available for robot. So if I write an expression, this is working up to better switch statements. So if I write an expression that is switching on robots, it goes, well, you covered vacuum and snowblower, but you didn't cover lawnmower. So the compiler can tell you that you've missed a case and enforce that you cover all the cases.
So this is in contrast to what we would do before this, which was we would have a bunch of implementations, and then the compiler doesn't really know all of the implementations that are possible. And so it can't give us a lot of information about, like, when we pattern match on something, like, oh, you missed this one. So it's just is constraining the number of implementations that we can have, so that the compiler knows what those implementations are and can give us better feedback. Another word for this is algebraic data types. And
nice.
Specifically sum types, which are the ability to use algebra as part of our type system to say that I've got a robot, and a robot can be a vacuum or a snowblower or a lawnmower, and it can only be those things.
And that's the sum?
That is the sum, because it's the or. Or is the whatever correlated to summing. In algebra. In ADTs, you will also have product types, and product types are actually a lot like records. So records can be looked at as the ADTs for product types. But the sealed gives us the ability to have essentially language support for the sum type in ADTs, algebraic data types. Okay. So then in our little code base, we've got a vacuum that can suck, a snowblower that can blow, and a lawnmower that can cut. Those are our 3 implementations there.
And they have to be final.
I think
they do.
You're right. Well, no, I think that you can actually tell it that they can be sealed, but then you have to tell it what you have to tell the permits on
those
what,
two.
Yeah.
But if you're not, then I think the compiler forces it to be. Well, I mean, you could take final out and see what happens.
Yeah. So I think it would tell us that it needs to be either final or
right there.
Sealed. And let's see. So it needs to be
sealed, non-sealed, or final modifiers expected.
So we maybe could do non-sealed. I don't know what that means, but anyways,
don't know.
Yeah, I can explore that later. Okay, so we've got our classes here that are our instances of our robot, and then we can do some interesting stuff with those. So we've got a method here, which is our robot stuff, and it takes just a robot, which is just that interface. And if we do things the old way with this, if we want to see, all right, we've got some logic that's like, all right, if the robot is a vacuum, then we need to go into this block, and then we're going to do a cast on that robot, and then we can perform some operation that's specific.
But we already
to
know
that
it's
robot.
a vacuum. Why do we have to cast it to a vacuum again? Because we checked already.
That's right. There's really some duplication there. Oh, and so there's this new way called pattern match. We got to do the air quotes.
It's like,
why,
I don't know how they came. I mean, I've seen pattern matching in Kotlin and Python and Scala, and this has nothing to do with this. This is really a smart cast.
Well, it's not even that smart.
Well, no, it isn't that smart, because you have to give it you have to create a new identifier for it.
So I'm calling it the type predicate cast.
Okay.
That's my name.
We'll go with that.
Okay. So what we're doing is now we're saying, all right, if the robot is an instance of vacuum, then we give it a identifier for this thing,
which is a vacuum type.
Yep.
So now we don't have to cast it
anymore. A vacuum, so we don't have to cast it. Yep. And so then we can call the operation on it.
So it's an improvement. There's no patterns. There's no matching. But
define patterns, define matching.
Well,
I mean, let's just call it a type predicate cast.
Okay. All right. Fine. All right.
But there is a new syntax for pattern matching that is partially or switch statements. Yep. Yeah. That is partially implemented with something already, and in a future version will become maybe stable or something. But right now you can enable the preview on Java 17 and get the new syntax, which for the switch statement, which allows you to do the type predicate cast, but do it in a switch statement. And so you can see I've got this comment out because I didn't enable the new preview syntax, whatever. But here's the cool thing, and where I think this all gets a lot more value.
And you got to use arrows.
Oh yeah, they're arrows. Yeah. So here's where it gets really cool and I think has a lot of value is that what we can do when we do the switch statement with these sealed, in this case, interfaces is the compiler will actually tell us, and I think in the case of Java, actually by default errors, which is good. In Kotlin and Scala, it actually is just a warning, but I like to turn it into errors. But anyways, it'll actually tell you if we haven't matched on all the cases. So if I were to like remove the snowblower case from there, then the compiler is actually going to fail and be like, hey, that you haven't actually pattern matched on all of the valid.
You haven't done an exhaustive.
Yeah, it's not exhaustive, and so so that's where I think this gets a lot more valuable. But that's still is preview. So so anyway, so that's the type predicate cast, which I'm just gonna stick with that.
Okay.
Yeah. Okay, so that is our quick run through on the primary features, Java 11 plus, so including up to 17. I guess we should have said up to 17 that we think are modern, things we can get excited about in the Java language.
Yep.
Yeah, and so
then there's a few others like modules, which is
working on wrapping my head around that one, but
it just basically allows you to have private classes, which we haven't had before.
Well,
okay. I mean, that's one aspect of it, but you have to reorganize your code into modules, and
it's a little tricky.
I think maybe and then
been through that with OSGI before. That was fun.
Yeah, and JShell, they've
so like an actual like shell for,
a REPL.
An actual REPL.
Yeah.
So that was we tried it for a minute. It seemed like it had good tab completion and
once again finally caught up to all the other languages.
Yeah. So I mean, modern, useful if you're doing Java. JPackage was something I haven't used, but it's a nice way to package an application with the JDK for distribution, and so it'll package in the Java virtual machine that needs to be used to run a jar file.
Would have been awesome to have with Java 1.
Yeah.
Okay.
All right. So if you do want the code, here's the code for those examples that you saw there up on my GitHub, Modern Java Spring 1. Okay, let's go on to a application where we try to bring some of these features and some other new features of the Java platform together. So I've got an application. It's up and running on the cloud using Google Cloud Run. And I think it just started that thing up from scratch and it loaded pretty darn quick. So that's good. And we're going to talk about that in a minute. But this is just a simple database-driven application. And I can come in and add in some data into my application. See, great, it works. It's storing data in a database. Awesome. And it's using a container, and we're going to talk about how all this is put together as we go. So this is our demo application that we're going to be walking through. This is using Spring Boot and Kotlin, and we'll see some other language features for the Java platform, and then some other just general platform improvements that we're seeing in the Java platform as well. So to start out, we're really into test-driven stuff, right? We do a lot of TDD, and so we're going to run the tests for this application first.
Is that what TDD means? Run the test first?
Run the test. Just start with the test.
If you say so.
Yeah. So let's run the test for our application. And this is where we're going to see one of my favorite things about the modern Java platform is when we run the tests, it just started up a Postgres server using something called test containers. And now it's actually running my tests against the actual Postgres database. So this would be an integration test where I'm actually testing that my integration with another system actually works. But as part of my test, it actually started up Postgres. And then it ran the test against my database, my actual Postgres database, and my test luckily passed.
And it initialized the database
and initialized the database. Okay. Yeah, it just did all that stuff for me. It passed the connection information for how to connect to this database to my test so that it knew how to connect to the database. And so all that, it just worked, and my integration test was easy and is portable. I can now put this into any CI environment, and I don't have to worry about the CI environment.
So I haven't done a lot of stuff like this. You're saying that this isn't the normal way of doing things. This is a new and exciting.
This is new and exciting.
Oh,
yeah. Because
Okay.
I don't know if I even want to tell you how we usually do this, but it's horrible.
It sounds hard.
It's horrible,
Okay.
and it allows for a lot of variation in the database that we're actually using to run our tests against. So sometimes what people will do is they'll use something called H2, which is an embeddable database, and they'll run their test against this embeddable database, which is not Postgres. But my production database is Postgres, and it's actually Postgres 13.1. And so I can now actually run my test against Postgres 13.1. And so I'm going to really try to alleviate as much variability between when I do local dev and when I do my tests, my integration tests, and when I do my CI tests, and when I do my production stuff. And so test containers allows me to do that. So it's using Docker. It's starting up a Docker container for Postgres, and then Spring Boot is able to connect to that Postgres database running in Docker, initialize the database, and run my tests against that. So test containers, huge, awesome part of the modern Java platform. Let's go jump into some code, and so we can see what's actually happening here. So this is the actual test that I just ran. So I've got a bar repo test, and we're in Kotlin now, but you'll see annotations, so similar to what you're familiar with.
I think you missed a whole bunch of semicolons.
Oh, that is a nice thing about some modern languages.
And shouldn't you have some new?
Yeah, we didn't even need a new there. All sorts of wonderful things that we'll get into. Okay, so my dependency for my test is a bar repo. And so let's actually go look at our bar repo. So our bar repo is a reactive CRUD repository. We'll talk about what that reactive means in a minute. But the object that I'm persisting in my reactive CRUD repo is a bar, and its primary key is a long. And you'll see up above that is a data class. So in Kotlin, we have something like a record. It's called a data class. And now we have the first property in my data class, which is an immutable value, which is called ID, and it's of type long.
And the ID does...
That's telling Spring Boot about the primary keyness of that property.
ID is the primary key.
Yeah.
Okay,
so we've got this bar object that we're storing in the database, but you'll see that this long has a question mark after it. So tell us about the question mark. That seems important.
Yeah, so that says that this thing can be null. And what it does is it tells the compiler how to handle this for the rest of its usage. So whenever you access ID, you have to add some extra syntax to deal with the possibility that it might be null. And you might be thinking, well, this is just like Java. Things can be null all the time, and you have to add that extra, you have to add a bunch of extra code to be checking for nulls all the time. The difference is that in Kotlin, you're generally using null as a sentinel or an indicator that you didn't get the result that you wanted. It's not like, oh, you forgot to initialize something and that this is a null pointer exception. So it actually has meaning. But when you interact with Java, you also have to, Kotlin will take care that you make sure that you deal with the possibility that Java could give you nulls. Is that close enough?
Yeah.
Okay.
Yeah. And I think the important point is that to add on to that is that the compiler is the one that is making you deal with the potential nullability that this thing can be null. Whereas in Java, you really just get a runtime exception that this thing was null at runtime. Whereas in Kotlin and Scala and other modern languages, with explicit nullability, the compiler is really trying to force you to deal with the fact that something could be null. And so you have to, in your code, address that possibility
everywhere
instead of just being able to potentially ignore an exception.
And end up with a null pointer exception. So basically the idea is to eliminate null pointer exceptions.
Yeah. Yeah. And so then we've also got a name property here. So here's our data class bar, and let's go back to our test so we can see here we create a bar. and we set that ID because we don't have an ID yet because we haven't persisted into the database. We set that ID to null initially. We cannot set this to null. Let's see what IntelliJ tells us if we try to set that to null. Is it going to let us do that? Nope. Oh, see, IntelliJ is like, and I think even the compiler is like, hey, you can't set that to null. That's not a nullable thing. So
because you didn't put a question mark on the parameter.
That's right. Yeah. Mm-hmm. Yeah, and so we create our bar with the constructor. So that's the way to construct a new bar. We don't have to do the new and all that. And then we call our bar repo.save. So that's our reactive CRUD repository has the save method on it. We give it our bar to save. But what we get back from save is a mono. So in Spring Boot, you may be familiar with the reactive stuff that they use, which is based on RX Java. So there's monos and fluxes are the way to be non-blocking. And so non-blocking is the ability for, in this case, when we call save, we're going to fire off a query to the database that is a insert whatever or update whatever.
And that's going to take a certain amount of time, and we don't want to wait around for it.
Yeah, we don't want to just consume a thread while we're just waiting for that response from the database to come back to say thumbs up, we're good. And so the reactive stuff that we're built on top of, which is R2DBC, which is the reactive database driver, in our case to Postgres underneath the covers, that is going to allow us to take that thread that's allocated for that moment that we send that request. And then while we wait for the response from the database, we're not going to have any threads allocated. So it's just a very efficient way to use our resources on the system. And so the mono and flux API that Spring Boot gives us, it's great because it's reactive, but when we're in the world of Kotlin, there's actually a even better way to deal with these reactive non-blocking things, and that's coroutines. So tell us a little about coroutines, and then we'll go into what this await first is doing.
So a coroutine doesn't use, it's a very lightweight way to handle a lot of processes that could, each of them could take a while. But the difference between coroutines and threads, especially in Java, is I think a thread takes, it takes some enormous amount of memory.
Just for each thread, yeah.
Just for each thread. And so there's a limit to the number of threads you can have. I did an experiment.
You certainly don't want to have millions, maybe not even tens of threads.
Oh, well, no, your machine will crash after, 700 or 800 threads or, depending on your machine. It takes a bunch of memory. And then there's the context switch, which is pretty heavyweight between one thread and another. Whereas a coroutine is basically like a suspendable function. It's like a function that you can say, oh, I've gotten to a place where I'm waiting for something, so I will suspend this and release the control to, generally there's a scheduler in there somewhere, and it'll find another coroutine that's ready to run, and it'll run that. And the thing is, these are super lightweight, so you can have, I think, millions of them if you want. And so it changes the way that you can design programs. I mean, you can design them around having millions of coroutines of that satisfaction.
Well, actually, not think about the resources that are underlying.
Right. Or the context switching, because that is also extremely fast.
Yeah.
I mean, it basically only saves what it absolutely needs to save. And whereas when you're context switching a thread, it's swapping out like the entire stack frame and the heap and all that kind of stuff. So it's expensive.
Yeah. So we've got this extension method here, and this extension method, which we'll talk about in a second, which is in the Kotlin coroutines reactive package, allows us to take what we get back from RX, the R2DBC stuff, which is a mono, and convert it into a coroutine. So we're just doing this adapter here with a wait first. So a mono can have a value or not, and a wait first is going to give us a coroutine that will get that value when it's completed. So tell us about the extension function, because this is really a nice modern language feature here.
These were originally designed for C# by Anders Heilsberg, who is a brilliant designer. And at first they look like kind of trivial, because it's like you can have a class and you go, I would like that class to have another function attached to another method attached to it, but I don't have access to the internals of the class, or I don't want to change it or whatever. You can basically just add this. You can just say, okay, this function can be called for that object. Now you can't reach in and ask for, access private stuff or anything. You can't break the rules, but the syntax that it allows you is anyway, it's quite liberating. It's surprising because at first you're going, well, you're just monkey patching a function on top of an existing class. But then when you see it in use, you realize, oh, well, that actually does a whole bunch more things than I imagined. It is a surprising feature. And I don't know if we would ever see it in Java because I think it would be too fundamental. But Kotlin has it, and Scala 3 has it. Yep. Previous Scala didn't have it.
And we think we're still investigating, but some people may call this ad hoc polymorphism. So it's not the typical inheritance polymorphism, but a different type of polymorphism that is based on an ad hoc ability to just add things onto the type system.
We're still trying to figure out what polymorphism
and it's based on
really
imports. So here we are importing this thing that is allowing us to then, in an ad hoc way, add something onto a mono, which gives us
which is why it isn't monkey patching, because you control it through namespaces.
That's right. Whereas monkey patching is just universal to.
That's right. Yeah. Anybody can change anything in Ruby, and everybody gets the effect, whether they've imported it or not.
So we've opted into this. This new functionality. Okay, so that puts us into coroutine land, where we're calling this save method, but then we're going to do our query using a find all method on our repo, on our reactive CRUD repo. And then we're again doing a coroutine so we can get our bars. But here we start operating on bars, which here's the magic of coroutines, is that this has all been async, right? When we go into coroutines, we are in async land because, computation has to end and then resume at some point.
Yeah, you fired both of these things off with your await first, and so they're out there waiting or working or doing whatever, and now you're actually calling bars. Yeah, and so now it has to actually wait.
It has to be there.
Yeah, well, if it's not there, it has to wait until
wait consuming resources.
Not wait consuming resources, right?
And there's the magic of non-blocking and coroutines in this case. So anyways, we're now asserting that the size is equal to 1 and that our ID is not null, because remember, ID was nullable. Okay, and that's our unit test. And one last thing here. For our unit test sake, we want to take the stuff that's happening in coroutines, and we actually want to take the whole block and block on it. We don't want our test to just like run this thing that's non-blocking and then be like, hey, I'm done, I got to the end, and it not have actually finished because we didn't actually wait on the things that were needed. So Kotlin has this way to basically say, hey, just take this whole block and wait until all the coroutines are done.
Right. So if you're familiar with the idea of a join, this is a sort of a different way of doing that. You don't actually call join, but the run blocking scope does it for you.
Yeah. Okay, so that's our unit test, and a lot of cool stuff that we saw in there. Let's take just a quick look at our actual application that we're using that we saw way back minutes ago. We see our REST controller, and our REST controller, it needs that bar repo, so that gets injected in. But here's where we get to see some cool stuff. So we've got a get mapping for /bars. This is our JSON API for getting our list of bars from the database. So we'll see that get bars returns a list of bar. But you'll see this special syntax here in Kotlin that says suspend.
And wait, get mapping is a Spring annotation?
That's a Spring annotation.
Okay,
yep.
So
that sets up the HTTP request for /bars. Okay. Yep, exactly.
Okay, so this is a suspend function.
Yep. So here we are not doing the run blocking. Here we are saying, all right, our HTTP controller method that we're calling, it's going to go off and do something async, reactive, non-blocking. And what we actually want to tell Spring is that this HTTP call itself is also non-blocking. So we now, from the way that this is going to work, is a request is going to come into /bars to get the list of bars from the database. And the suspend function is going to call this find all method. So it's going to go do that query. But then the database is going to be like, hey, I need to go look that up. And in that time, what can happen is that the actual threads and resources allocated to this request, this HTTP request that has come in, can actually go away. So it can actually just say, hey, just I'll come back to you in a little bit, but I don't need any resources right now. And then as soon as the database responds with, oh, I got your list of bars, then all of a sudden this scheduler, this IO scheduler, Java NIO that this is built on top of, all of a sudden gets a notification that says, all right, somebody wants to talk to you. They've got your list of bars for you. And so then all of a sudden things get revived. And now it takes my list of bars and serializes them into JSON and then returns them in the HTTP response.
So basically, this server can handle this request and then go back to and handle this request in a suspending way, and then going back to waiting for other requests.
That's right. It can go do a bunch of other things while we're waiting for the database to respond.
Which is what you want all of your servers to do. You don't want them to be sitting there waiting
That's right.
for the result of a single request.
That's right. So it's just is a great way to take advantage of resources on our machines, be much more efficient. And Spring has great support for suspend functions, coroutines in Kotlin, and of course for the underlying RX Java APIs as well. But great that we can be non-blocking all the way through from the request handler, our HTTP service, down to our database with R2DBC.
Because in the past, people have gone and jumped through tremendous hoops to get the same kind of responsiveness from their server. And this is basically just built into the language.
Yep. And in our case, in Kotlin and Spring Boot as well, with the reactive support that they have. So, and then, of course, we're doing that on our post handler as well, where we can go in and add bars into the database. So, okay, so that's our actual HTTP service that's running.
And then here's...
Oh, do you want to see some nullability stuff?
Yeah.
Okay. So our save method, it could potentially fail, right? And so instead of calling the await first that we saw before, we call await first or null. And so now we have a nullable thing, which I don't remember what our I think it actually returns a mono of a bar. But so this is saying, hey, you may not have gotten a bar back. And
so null doesn't mean failure, lack of initialization or anything. It means, something, whatever you were expecting didn't happen.
Yeah.
But now we have to deal with the null.
That's right. We need some explicit handling of what happened if it was null. What do we do? And if we don't deal with that correctly, we can either propagate it out and let someone else deal with it, or the compiler is going to give us an error and be like, hey, you need to deal with your nullability.
But in either case, the compiler ensures that you handle that case.
That's right. Yeah. Okay, so in the case that we did have a bar come back, so our save was successful, then we return a HTTP response of no content, and then we have a fallback case using, what's that called, the Elvis operator?
Yes.
So the Elvis operator says, all right, if that was null, then we're going to return an internal server error. So pretty, we probably want to do a little more in the real world than that, but that just gives us a basic introduction to null handling, essentially. Right. Okay, so that's our application and how that works. And now let's talk about containerization, because one of the things that I think is, along with test containers, that's really awesome, is the ability to turn our applications into containers that we can run anywhere in our application. So we can take containers and we can run them with Docker. We can run them on Kubernetes. We can run them on cloud services like Google Cloud Run, whatever. Containers are portable, and that's a really great thing about them. So let's talk about how we create containers. So Spring Boot has built into it the ability to turn our source code into a container. And the container is everything that is needed to run our application. And so let's go run the actual thing that is going to create our container, which is built into Maven and Gradle tasks for Spring Boot. And in the case of Gradle, it's boot build image. So we're going to create a container image, and we give it the image name that we want to create. And that's going to go off and create for us a Docker container that then is that portable format. And I'm not going to actually let this run. And the reason why is because it will just slam my CPU for a little while.
It's already
Yeah,
blowing
the
the fan.
fans are going off, and so I've already actually run through this. It takes a few minutes, and the reason why this is processor intensive is that we're using something called GraalVM and Spring Native to create a very optimized version of this application, and we'll talk about that in a second. But before we talk about that, let's talk about the actual method of containerization. So to create a Docker container, if you've done this before, you may be familiar with a Docker file. A Docker file is a list of instructions that Docker uses to create a container image. And these get unwieldy really quick when you have to deal with security and you have to deal with, all right, I've got to pull in some other information from somewhere into this container. And it gets hard to maintain Docker files, and you end up doing a lot of copy and paste. So there is another way to create Docker containers, which is using build packs. So the Cloud Native Computing Foundation created this standard called build packs, and build packs are a standard way to take really almost any source code and turn it into a Docker container. We're using the Paketo build packs. Those are the default in Spring Boot. So when we run that boot build image, it actually underneath the covers uses build packs to compile our application into the jar files that are needed, and then do whatever else is needed to assemble this thing into a layered container format. So containers are layered. So we've got like the operating system, we've got the JVM, we've got the jar file dependencies, we've got our actual application, we've got all these layers, and that makes for a great cacheability of this container when we actually use it and we need to pull it down. We can cache those things easily because they all have a SHA for each layer. So anyway, so we create this container image that has everything that's needed to run, and we then can move that container image around into different runtime environments, whether it's Kubernetes or whatever. So Paketo build packs are what's actually doing that work of taking my source code and turning it into the container image. But if we go take a look at my build.gradle.kts, I told my, this is the boot build image task in Gradle, I told it that there is a environment variable BP native image, and I set it to 1. And so this now turned on Spring Native and GraalVM, and that is going to create a very optimized version of our application. But before I go on to GraalVM, did everything about build packs make sense in containers?
I think so. The goal is, I think, to make something that starts up really fast, right?
The GraalVM part is.
GraalVM part.
The container is just the portable way of moving an application around to different environments.
Okay.
Yeah.
That sounds nice.
Okay, so the GraalVM part, what it's doing is it is doing ahead of time compilation on our application to compact it down. So the JVM definitely has overhead. It has startup overhead. It's got overhead for doing all sorts of things. I don't know the
Like how much overhead?
So much.
Can you show us?
Oh, should we show them?
Sure.
Okay.
Let's see how much overhead.
Okay, so if we just go and run our application and see what the JVM overhead of running our application is, let's go. Oh, first, before I do that, I need to go start up my Postgres instance. So I'm using Docker. I'm starting up a Postgres instance manually just to show you stuff. Really, the only time I ever really start up a Postgres instance is for production, unless it's being started up for me automatically with test containers. But so I started one locally. I do need to go initialize the database. So let's go run our database initialization. Okay, so that ran. Okay, against our database. Now let's go start up our application. So this is going to run our application just on the JVM, and let's see how long it takes. And we can ignore the Gradle parts that are, doing a bunch of work ahead of time, and we'll just see how long it takes for the actual application to start up and run here. So it'll take a minute to go through all the Gradle tasks that need to be run to get everything ready. But then there we go. We've got our application started, and it took 2.4, almost 2.4 seconds to go just for the application startup time. And this is not using test containers, so that's not part of this.
That's what you would see on your cloud server or whatever.
That's right. Yeah, if we're in a production environment and we're running against the JVM, 2.4 seconds essentially to start up our application.
Which could build up.
And I think we could let's try to go load this thing here. Here we can see. Yay, it works. Okay.
It's working.
So our application is working. Let's close that thing down. Now, I used GraalVM native image and Spring Native to create the ahead of time compiled version of the same application, and that went into the container image. And so now we can go to Docker run, tell it to run this thing. I give it the information for how to connect to the database. And then I tell it the container that I want to run, which is Kotlin bars. And I don't want to do a init because that initializes the database. Instead, I just want to run it. And so now let's run the Docker container with that GraalVM-ified version of this.
So this is running the binary then.
That's right. This is running the binary that's been ahead of time compiled. So no JVM. Like the JVM is gone. It's using something called Substrate VM. And remember, we were learning about that, how it's not at all the JVM. It's a totally different thing.
But it provides things like garbage collection and stuff.
That's right.
And memory management.
Yeah, thread allocation to the underlying operating system.
Okay.
All that kind of stuff. So I just started up that same exact application, and now it took 0.112 seconds instead of 2.4. So that's 20 times
roughly
faster.
Yeah, something like that.
Something like that. I'm bad at math, but I do like algebra.
Mm-hmm.
So our application is starting up much, much faster. And so this is a very simple application. There are Spring applications that take a lot longer to start up. And this is one of the primary ways that we can deal with something that's called cold starts.
Mm-hmm.
So in a dynamic scaling environment, whether it's serverless, so like Cloud Run is serverless, or if you're doing Knative on top of Kubernetes, these are serverless environments that are going to auto scale up based on the requests that are coming in. So what happens is that if your demand for an application, so the number of requests coming in exceeds your supply that you have allocated, the number of like actual instances allocated can handle that demand coming in, then you need to scale up. And if a user has just pushed checkout on a cart and all of a sudden they're sitting there waiting because your application is going through startup mode and having to connect to databases and refresh caches and start up the JVM and do a bunch of reflection, whatever, then the user is just sitting there thinking that something went wrong when they hit that checkout button, and that's bad. You don't want that. No. And so we want to avoid those cold starts as much as we can. And so we can do that. One of the pieces of doing that is using GraalVM native image to ahead of time compile it, so we don't get that overhead of doing all the JVM startup stuff that we're used to.
Plus, it would reduce the cost of your service, right?
Potentially. GraalVM also typically uses a lot less memory because it doesn't have all the same garbage collection memory allocation stuff as the JVM. So maybe you're saving some money there. But the ability to, start up lots of instances very quickly, use less memory, that definitely could have some impact on saving money.
Responsiveness.
Yeah.
Okay.
Yeah. So there's a lot of good reasons to use it. The nice thing is, as you've seen, it's just built into Spring. Like all we had to do was set one parameter in our Gradle build, and all of a sudden we got all those benefits. Now it's not all like rainbows and unicorns. I don't think I had to do it in this application, but one of the things that is a challenge with ahead of time compilation is that reflection is dynamic. It's something that is not able to be ahead of time compiled.
You can't compile it out.
Yeah, because you're using like strings to access things, and so it's dynamic. And so Spring uses a lot of reflection traditionally, and so what the Spring team has done is they've done these hooks into Spring to make Spring able to be to fit well with GraalVM and the information that GraalVM native image needs about the reflection points. So it's not that GraalVM native image can't do reflection. It's just that you need to declare those reflection points to GraalVM when it does that ahead of time compilation for you.
So that it can work around them however it does.
Whatever magic it uses to work around them. Yeah. And so the nice thing is that the Spring team has made a lot of that just transparent. Like you don't see any information in here about the reflection points, anything that I had to do because of the Gradle plugins and the work that the Spring team has put into that. So it's nice, but it is really just providing some information to GraalVM about the reflection points. A lot of the work that you and I do in Scala now with Scala 3, we're not using reflection. And so we don't have some of the same issues where we don't have to declare reflection points because we're using type classes and some other fancy language features to do some of the things that reflection gives us in the Java and Kotlin ecosystem, but without actually doing reflection. So
it's deterministic.
Yeah, I like deterministic. I like math. I'm not. What would I say? I like algebra. I'm not very good at math, but I like algebra.
It's a subset.
So, yeah. So, anyways, GraalVM and native image and Spring Native, really, they're giving us this like instant startup time, a lot better responsiveness with our container images. Also, a lot smaller container images. So when we do that ahead of time compilation, we don't have a JVM. So let me see if we can actually do this real quick. This will be a fun on the fly thing. There's this cool tool called Dive where we can actually go look into a container image. Let's see if we can go look at our Kotlin bars. Whoops. Oh, I didn't install Dive. Anyway,
Dive tool.
Cool Dive tool. So Dive, you can install Dive, and then you can actually go look at what the contents of your container image and see what's actually in it. And if we were to go look in the Dive through Dive to Kotlin bars, we would see that there's this really small operating system that's in our container image, and then there's this like binary that when compressed gets down to like 40 megs or something like that. So our whole container image goes from huge operating system with huge JVM with all our jar files down to a container image that's like 40 megs in this case. Or
so it sounds like just from an educational standpoint, Dive would be a nice thing to look at so you get a sense of what's going on.
It is. And I have another presentation called Comparing Dockerization Methods or something like that, where I use Dive to like go through all these different
things. And they can find that on YouTube?
Yeah.
Okay, cool.
Yeah.
All right.
Yeah.
We're down to the last few seconds here.
Okay. Well, that was
everybody.
Fun. Yeah, thanks for joining us. Join us in the Zoom room
and listen to our podcast.
HappyPathProgramming.com. .com. Thanks.
Hi. Thank you so much for that really interesting talk on all they're really exciting. I actually learned a lot in this last talk. Check out their podcast, the HappyPathProgramming.com. I'm definitely going to check that out. Up next, we're going to have microservices testing at scale with Kishore and Sindhu, both architects at Discover, and they're going to be talking about how they perform tests at scale in Discover. In the meantime, check out the Q&A if you'd like to talk to James or Bruce, and they'll be in a private Zoom room. So go to the Slack, and you'll have a link there that you can access that Q&A. In the meantime, we're going to have a short break until 2:05 Mountain Time, and we'll be back with Discover with microservices testing at scale. Thank you.